Howdy students, ready to talk about a little radian measure. We've got right here our definition. A radian is a measure equal to an angle at the center of a circle whose arc is equal to the radius. An intercepted arc, the arc contained between the rays of an angle. Now that sounds really fantastic. What I'm going to do here is I'm going to draw you a picture of what all that means. So I've got a circle, and a radius is going to be the angle made from the center where the arc length created by that angle is equal to a radius. So this would be a radius, this would be a radius. If this were 2, this arc length would also be 2 of that unit. That is the definition of a radius. Now, that doesn't make a lot of sense when you're used to dealing with degrees, but it's actually not too bad. One of the things that I like to think about is the entirety of the circle. So example, the entirety of the circle is 360 degrees, and everybody just kind of accepts 360 as a total number of degrees with no real question as to why they come up with that number. But we could show you why they come up with the total number of radians for a circle. So this would be an angle of 1 radian, because the angle opens up to be 1 radius length of the circumference. Well, the entire circumference, 2 pi r, would represent the entire circumference of this circle. A radian is equal to 1 radius, and so I can take and substitute instead of r, I can substitute a 1, and that means that the entire circle will be equal to 2 pi radians. And from there, everything becomes very similar to your degrees. As an example, 360 is the entirety of the circle. If I went down, and we'll get another circle right here. If I did a fourth of this circle, and I asked for this angle in degrees, it would be a fourth of 360, or it would be 90 degrees. That makes sense. 90 is a fourth of 360. It represents a portion of that because this is a portion of the circle. The same thing is true if I measure in radians. 2 pi is the entirety of the degrees that's necessary to make a circle. A fourth of that, dividing this by 4, will leave me with pi over 2. So this is just a portion of my entire circle, which would be 2 pi. It's a fourth of it, so pi over 2. So pi over 2 and 90, same measure. One is in degrees out of a total of 360. One is in radians out of a total of 2 pi for the entire circle. And that's really just about it for that. Continuing on with our notes, you've got this handy dandy little formula here. They want to know if we have a circle with a radius of 5 and an arc length of 10 pi, what would be the measure in radians of the central angle. Now if I look at a circle with a radius 5, some of you might immediately say that circumference is 10 pi. That's the entire circle. So of course my answer would just be 2 pi radians. And there are lots of different ways you could put radians. Central angle is one. RAD is another one. I prefer RAD because central angle kind of looks like a degree symbol. So I'm going to take that away. It's going to be 2 pi radians. To fill out our formula, if you didn't know that immediately by looking at your numbers, the central angle that you want in radians is equal to the arc length, which is 10 pi, divided by the radius. And that's it. 10 over 5 reduces to 2, and we'll get 2 pi, and again, radians. So however you want to do it, both ways work. Let's get in here. Find the measure of the central angle in radians. This one. And remember, 2 pi is about 6.28. So your angles are going to fall as long as you don't start rotating. Your angles are going to fall between 0 and 6.28. And then just like a degree would fall between 0 and 360. Continuing on, we want this central angle. Our arc length is 11 feet, and our radius is 8. So this is going to be, 1.375 radians. I mean, fantastic. I'm going to put a rad on that. We'll leave it as a fraction. But I put a smiley face. It makes it hard to put the radians on there. Anyway, so just arc length over radius. That'll give me my radians. This one, you've got arc length, which is 6 pi, over radius, which is 12. And that's going to be equal to my central angle in radians. That's going to be pi over 2. And if you think about pi over 2, this one's easier to go back. Our total circle is just 2 pi, so this is a fourth. That's a dead giveaway that this is not in a really good, doesn't illustrate the picture really well. It's not a good scale. This would be a fourth of the circle, or 90 degrees, pi over 2 would be. But it's pi over 2 radians. This one, you've got a fractional arc length, but don't let that discourage you. It's just 3 pi over 2 is my arc length. I'm going to divide that by 3, which is my radius, and that'll give me my central angle. The 3's will cancel, the 2 stays, and your radians will be pi over 2. And again, radians. Should really pick a lowercase or an uppercase. I'm just getting kind of crazy with that. But anyway, that's that problem. Let's get on to the next page. This time they're going to give us our central angle in radians, and they want us to find the arc length. So I know my central angle, 3 pi over 2 radians. Arc length is m, radius is 19. All I'm going to do is move that 19 to the other side using a little multiplication. That's going to give me 38 over 3. Slap that pi on there. That'll be my arc length. And my units, centimeters. All right. M was a poor variable choice. Moving on. But it's 38 pi over 3 centimeters. And remember, this is just a number. This is 38 times 3.14 divided by 3. So you'll get 40 something. It's really not so bad. This one. Now, 2 ways to do it. I'm going to show you the way that I like to think about it. The entire circle is 2 pi radians. And this portion of the circle that we're not using to find the arc length that we want is 5 pi over 6. So if I take 2 pi and I subtract off 5 pi over 6, I'm going to get 7 pi over 6, or 12 over 6 would be the total here, just to show you where those numbers are coming from. So 7 pi over 6 is this angle right here that opens up to the arc length that I want. And that'll be equal to the arc length that I want divided by the radius, which is just 4. I'm going to multiply both sides by 4, and that's going to give me 28 pi over 6 is equal to W. I can go ahead and reduce this, divide both of them by 2, and that'll give me 14 over 3 pi is equal to W. Don't forget about those units, because we are dealing with a length, and it's going to be centimeters. On number 3, same thing. They give us a central angle of pi over 3. I'm going to set that equal to the arc length that I want, which is C, over the radius, which I know to be 2. Multiply both sides by 2. 2 pi over 3 is equal to C. Don't forget your units. This is in feet. And that'll be it. To give you just one more heads up, if you ever wanted to convert between radians and degrees, I'm just going to set one up. An easy one is the 90. So you think of them as a portion of their total. So 90 degrees is a portion of 360, just like whatever radian you would need is a portion of 2 pi. And from here, you can quite literally simply cross multiply and solve. I would always reduce. You'll get 2 pi is equal to 4x. You'll divide by 4. And just like we talked about, it's a fourth of that total. And you'll get pi over 2. You can also take, and if you wanted, if you had a radian and you wanted degrees, you could do it the other way. Your x would be here, and your radian measure would be here. Good luck. We'll see you on Monday.